Hello everyone, you're welcome back to my class. In today's class, we're going to continue from where we stopped, and that is question 2. So question 2 says, state a similarity between vectors and scalars, right? Remember vector and scalar quantity. So any quantity that can be described with just magnitude simply means size, without direction, that is said to be scalar. But when you can describe a certain quantity with both magnitude and direction, then such quantity is said to be a vector quantity. So question 2a, what is that thing that is common between vector quantity and scalar quantity? So from the definition, both vector or vectors and scalars have a magnitude. They both have magnitude. So that is similarity between vector and scalar. Is that understood? So if the differences, in terms of differences, vector has both magnitude and direction, while scalar quantity has only magnitude but no direction. Is that clear? So that is about question 2a. So question 2b. Question 2b said a block of mass m slides down a plane inclined at 30 degrees to the horizontal. Deduce the expression for the force acting on it along the plane. The force acting on it along the plane, and take g to be 10 meters per second squared. So let's take this ruler as the plane surface, right? So now it's on the table horizontal. So if I place a body on it here, so if I place this body on it, so the force acting downward is the weight of this object, right? And also the ruler also exert equal and opposite force, which is known as normal reaction upward. So in that case, we will have something like this. Let me use ruler. So we have something like this. So the body is here, right? And here it has a force, the weight of the body will be acting downward. Is that correct? And it has equal and opposite force, which is a normal reaction acting upward. But if, for instance, this body here, now here is the object, here, and now lift this to incline this object, what happened? It slides down. Is that correct? It slides down. So now sliding down is because I have lifted this plane and acting it at an angle to the horizontal, just the way we lay our ladder against the wall when you want to climb something, right? So in that case, now if here is the initial condition of the plane, right? Now here is the plane. So I now leave this plane and incline it at an angle 30 degrees to the horizontal. Here is incline, right? At an angle 30 degrees to the horizontal. So I raise this object at an angle 30 degrees to the horizontal, as you can see. So it was here, right? Then I raise it just the way I did the ruler and the block of wood, and acting it at an angle 30 degree. So this is what the question is talking about. So the object is now inclined and at the verge of sliding down the plane. So when it is like this, we have that the weight of this object will be acting downward. The weight of the object will be acting downward, which is this. So here is the weight of the object, W. And the normal reaction is always perpendicular, just the way this normal reaction here is perpendicular to the weight, right? To the plane. It's always perpendicular to the plane. So here is the normal reaction, which is always perpendicular to the plane. So here is our normal reaction. So we call this normal reaction R. Some textbook we use N. Are we together? So that is your normal reaction. Now the next thing to do is to resolve this weight into vertical and horizontal, that is along the plane, and what? Vertical, right? Which is perpendicular to the normal reaction. So doing that, I will have this, the vertical component of the weight will be this one, which is equal but in opposite direction to your normal reaction. So here is the vertical component. I'll call it WY. Are we together? And the horizontal component, or the component along the inclined plane, which is this, I'll call it what? WX. I hope we are together. WX. Is that correct? So let's put an arrow because it's a vector quantity. So when you do this, it is observed that the angle here, which is the horizontal angle, is equal to the angle here. It's also 30 degrees. So if here is 45, here will also be 45. In our next class, I'm going to show you how we arrived at angle B equal to this. Is that correct? So, but based on what we have in the question, so we're given this and we asked to find the force acting to the plane according to the question. So we asked to calculate deduce the expression for the force acting on it along the plane. So our target here today is going to be on WX, which is the force acting on it, on this body along the inclined plane. Don't forget that this body has a weight of what? A mass M. Is that understood? So from here, in order for us to get that, we take this inclined plane, we take it down to this point to form a right angle triangle. This inclined plane, we come here. So I have a right angle triangle here, and this still become the horizontal component, the component along the inclined plane, which is WX. And this one vertical, I can still put it here so that it will be at the side of my WY. Is that correct? So, and here will be my the hypotenuse part of it become my W. So I have a right angle triangle here. I can now use what? I can use trig ratio to find what I am looking for. So if you look at this angle is facing this side, and we have the hypotenuse. So our target is the WX, which is the force acting on this body along the inclined plane. So opposite of a hypotenuse, that is sine theta, is equal to what? Opposite all over hypotenuse, right? So that will be imply that sine 30 degree will be opposite, which is WX all over hypotenuse, which is W. So here now, when I make WX subject to the formula by crossing multiply, I'll have WX is equal to W multiplied by sine 30 degree. So W in terms of mass will become mass times acceleration due to gravity, mg, multiplied by what? Sine 30 degree. So that will be equal to m, and we're giving g to be 10, multiplied by sine 30 is simple as 1 over 2. So this implies that WX is equal to here 1, here 5. That will give us 5m in Newton. So this is the expression for the force acting on this body along the inclined plane. Is that understood? So if, for instance, another question, you have to find the expression that is equal to the, or acting perpendicular to the body, that will be the vertical component of the weight, which will be Wy equal to W cos theta. Is that understood? I think we should stop here in our class today and continue from here in our next class. Thank you for your time. See you in the next class.